Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 24th, 2025, about 4 days ago. It shows that a single mobile robot can act as a rolling data factory, boosting a vision language model for multilingual book identification from 32.0% to 71.8%, and nearly doubling tough multilingual optical character recognition scores from 24.8% to 46.6% in English, and from 30.8% to 38.0% in Chinese. The paper is titled Robot-Powered Data Flywheels, Deploying Robots in the Wild for Continual Data Collection and Foundation Model Adaptation. And as we will see later, the implications for how we adapt foundation models in messy real environments are pretty striking. Alright, the previous segment introduced the big performance gains, and Figure 1 now illustrates how the robot-powered data flywheel actually works. The left side shows the Scanford robot autonomously driving along library shelves, capturing close-up images of multilingual book spines. The center diagram shows those images flowing into a vision language model, which creates a curated real-world dataset and fine-tunes itself. The right column of photos tracks deployment over several days, where vision language model success rises from roughly 30% on Monday to about 70% by Friday. So while Figure 1 focused on the feedback loop, Figure 2 highlights why the East Asia library is such a tough, real-world setting. The top panel shows the same shelf region across 2 weeks, with different shelf heights, backgrounds, and lighting that constantly change the robot's viewpoint. The bottom panel zooms into specific book spines, illustrating damage, occlusions, and fading or aging of multilingual labels, which makes reliable recognition genuinely difficult. Alright, while Figure 2 emphasized how messy the shelves are, Figure 3 shows how quickly the flywheel improves performance as the robot gathers data. The left panel tracks book identification success, where the fine-tuned model rises from roughly 1/3 to about 70% within only a couple of hours. The middle and right panels show English and Chinese optical character recognition, which also nearly double or substantially improve. The flat dashed lines mark the weaker pre-trained baselines, so the green curves highlight how valuable just a few hours of targeted data become. So while Figure 3 focused on accuracy gains, Figure 4 ties those gains to concrete human effort. The left photos contrast autonomous robot scanning with a librarian manually scanning shelves, which makes the task difference very tangible. The center plot shows Scanford steadily scanning more than 2,000 shelves over 10 days, saving roughly 19 hours of librarian time as accuracy improves. The right table lists only 26 brief human interventions across the entire deployment. So the big takeaway is that a single robot in a real workplace can act as a self-improving data engine, both doing useful work and dramatically upgrading its own vision language model. More broadly, this hints at hospitals, warehouses, and stores running similar flywheels. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.